In this video, we're going to have a look at the addition and subtraction of algebraic fractions. Before we start addition and subtraction of algebraic fractions, let's quickly recap what happens for normal fractions. Here we have two fractions that we want to add up, and for that we need to get the lowest common multiple for the denominators. And here that is 36. To do this, we need to write equivalent fractions for each of these terms that have a denominator of 36. If we now take 1 over 12 and rewrite this with a denominator of 36, you need to realize that in the denominator we multiplied by 3, so we have to do the same in the numerator, and that will give us 3 over 36. We will do the same for 7 over 18, so we want an equivalent fraction with a denominator of 36, and this means you have to multiply the denominator by 2, repeat this by multiplying the numerator by 2, and that will give us 14 over 36. And because the two denominators are now the same, we can add up the numerators, and this will give us 17 over 36. Here, the lowest common multiple almost came naturally, but you need to realize that 12 is actually written as 2 squared times 3, and 18 written in prime factors is 2 times 3 squared. The lowest common multiple is then formed by taking the biggest exponent for the base 2 and the biggest exponent of base 3, and this is where 36 comes from. When determining a lowest common multiple, you need to remember that you can never make any denominator smaller than it already is, and that is why we take the biggest exponent. And this is a very important concept to remember when we now move on to algebraic fractions. Example 1. Simplify. Here we are given 3 terms that we need to subtract and add. Here we then need to start off determining the lowest common multiple. If we have a look at the 3 constant values, the lowest common multiple is 18. And as I've mentioned for the variables, we always take the biggest exponent, which means that for our x's, we will have x to the power of 3 in our lowest common multiple. Even though only one term has a y in the denominator, we can never make any denominator smaller than it is, so y will be part of our common denominator. Next, we need to determine the equivalent fraction for each of these terms with this new denominator. The 6x was multiplied by 3 and by x squared y, so the same has to happen in the numerator, and then we'll have 21x squared y. In the second term, the denominator was multiplied by 2 and x squared, and repeated at the top, we will then have minus 4x squared. The last term was multiplied by 6 and y, and then at the top we will have 6y. And because there are no like terms in the numerator, this is the final answer. In example 2, we need to simplify by subtracting one fraction from another. So again, we'll start off determining the common denominator. When a denominator consists of more than one term that cannot be factorized, the denominator as a whole is seen as a factor. So in these denominators, we have 2 different factors, and there's nothing we can multiply the one factor with to change it to the other factor. Therefore, each one of these 2 denominators should be in our new common denominator exactly as they were. Next, we once again need to determine the equivalent fraction for each of the original ones on this new denominator. Here, it helps if you write your numerator as well as denominator in brackets. In the first term, we multiplied the denominator by an extra bracket, x plus 2, which should now be repeated in the numerator. And in the second fraction, we multiplied with the extra bracket x squared plus 2, and this should also be repeated in the numerator. All that's left to do now is to multiply out the brackets in the numerator, and lastly, we need to add up all the like terms. In the next video, we'll have a look at fractions where the denominator should first be factorized.